Okay, next review video. I was thinking too, now that it's already Sunday, if any of you have certain burning questions you'd like me to do from either any of the reviews, if you want to email me those, I can sort of jump to that one. I'm just kind of going through this in order, I think, of what will be most helpful first. But if I'm wrong and you got something you really want me to do first here on Sunday, I will do that for you. I'm open to requests. Okay. Um, Also, not sure of when I should stop doing this, like how late in the evening it's going to be valuable for anybody. Okay, but here we go. Find the surface area of the area of this thing below. Now, the surface area, remember, is the one that's kind of weird. Surface area, you got to be careful because it's not just like I'm taking this cylinder plus this cone. It's a little more complicated than that. Volume, yeah, you could just say you're building this thing and you want to know how much Play-Doh that takes, and then build this thing and know how much Play-Doh that takes, and stick them together. You've got the total volume. Surface area is about how much exposure there is to stuff on the outside. So I always like to start at the base sort of and build the thing up. This is if you're going to build this thing out of paper, or just the shell, or you're just going to paint the thing if it was changing its color. So the first thing you'd worry about if you're going from sort of left to right on this one is there's this flat circle. So we have area of a flat circle plus the next thing would then be this kind of round um, lateral area of this cylinder, the shell around that part, and then the roof or the cone or the shell around the top, which is just the lateral area of the cone. And then if I built all those three parts and stuck them together in this order, I have this whole rocket shape here. There's no flat circle in here, and that was the biggest problem people were having when they did this kind of combined shape on the quiz. They'd find total area of a surface, total surface area of a cylinder, which includes this base, and then they would add that to the total surface area of the cone, which includes this base again, essentially counting this base twice when it shouldn't even be counted at all. So I wouldn't jump straight to the especially full surface area formulas for any simple shape. I would think of these faces kind of separately and add them up as you need to. Okay, so pi r squared for this circle, which isn't bad. Lateral area of the cylinder, again, not bad. This is a perimeter times height. Perimeter is 2 pi times 4 times the height of the cylinder, which is 16, plus area of the cone, which is half, times perimeter times slant height, which we have. So we don't really need to Pythagorean theorem our way through any of this stuff. It's all there for us. You just had to know this plan and how to do these separate formulas. This was pH, and this one was half PL. Okay, so this is just now computation. 16 pi, this is 16 times 8, yuck. Or 32 times 4, which I believe is 128. And half times 2 cancels it itself out. I've just got 60 here. Okay, 188, 198, 204 pi. That's what I get. Okay, there you go. All right, this is one of those sections of a sphere things. I like this one because it's kind of a little bit off center. It's not going straight up. That may make life a little bit easier. Okay, while making his lunch, Alexander decided a portion of his grapefruit. If the area, okay, we know the area first. That's a little bit unusual. The area of this sort of shaded face is 3. Oh, it doesn't even have a pi in it. And the diameter of the grapefruit is 5. So you know what? I'm going to draw in a radius here and call it 2.5. Radius is usually a lot more useful than diameter. Find the distance between the center of the grapefruit and the slice. Okay, so we're looking for this x. Assume that the grapefruit is a sphere. Well, thank you very much. I couldn't do much if I could do that. All right, remember the radius of a sphere is the distance from this center point to any point on the sphere. And I need to probably be able to figure this out. It might be a good idea. Since they gave me this area, I'm thinking, okay, what's this area going to be good for? The only thing I know about area of a circle is that it equals pi r squared. So from area, maybe the only thing I can find is radius. So let's think about that for a second. Could I find the radius of this circle? I'm going to draw it right there. I could draw it this way too. Actually, it might make more sense to more people if I do it straight up that way. So I'll draw it this way to be a little more enlightening. All right, so the radius of the circle, maybe I should call that something else. Let me call that y, just so we can keep stuff separate here. So I'm going to call this radius of the circle y, because I have that radius and I also have, I'll call this one r, radius of the sphere. Because they're different. Radius, I mean, this is obviously a smaller circle than this great circle that's in here that's in white, this 2.5, this is bigger than this. As we move farther away from the center of the sphere, those circles get smaller. Okay, so this is supposed to be 3. So I can figure out what y is going to be just from that. Y squared then is 3 over pi. You don't get to do that very much because usually in your book you get stuff where if you have to divide something by pi, they build a pi on here and then you just cancel it. This is a little more messy. All right, square root of 3 over pi. Great. And then I don't actually have to know that. Y, now I've got this y, I'm looking for this x. I've got those in a right angle situation, but guess what? I also know this thing here. I know this hypotenuse. That's exactly 2.5. That is a radius of the sphere. This point is on the sphere. This is the center, so that has to be 2.5. So I know now that 2.5 squared plus, no, equals, that's the hypotenuse, equals x squared plus the square root of 3 over pi squared. See why I didn't get the calculator out? Because I'm just going to square that anyway. So 2.5 squared, that's 6 1/4, equals x squared plus 3 over pi. If I square that, it just takes the square root off. So x squared is 6.25 minus 3 over pi, and then take the square root of that. So that's the exact answer for x. I don't know if I'd expect that or not. Probably not. You could probably just do this this way. Let's take 3 divided by pi. What? Can I get rid of that? Does that just do that? Okay, good. 3 over pi, takes 6 1/4 minus that. What is up with my clicker today? 6.25 minus, hello, minus that. I'll take the square root of that. No, not square it. Second. Okay, and it's about 2.3. Really close to 2.3. Okay, so it's almost really to the end of the sphere. I mean, if this is radius all the way to the end, I mean, to the surface of the sphere is 2.5. This is 2.3. It's pretty close. Okay. All right. This one is really test what, like, warning. Yeah, you might want to know this one. Okay, so this is called a truncated pyramid. This bottom thing here. There's been a top chopped off of this this pyramid here. So the job here is to find the volume of that thing. They tell you that the height, let's draw the back side of this thing down here. The height down to this floor at one time, before they chopped it apart, was 12. This height was 12. So we're supposed to find the volume of the bottom part. Volume for this truncated thing, we're going to go volume of big minus volume of top. And we're going to get our answer. Big thing would be, of course, we'll do there, and then we're going to find the part of the invisible, the volume of the invisible one up here. Okay, so for this, we're going to need 1/3 area of the base times the height, no problem, minus 1/3 area of the base times the height. Okay, now we got a problem. We don't know what this height is from here to here. We don't know that. Well, that is in a right triangle. Where we know this little thing down here. I guess we don't know this line height, do we? Nope, we got to do this way. Look at this. I'm going to label some points here so that... Do I want to know... Yeah, no, this will be fine. Yeah, this will work. Let's just do it that way. Okay. We're not going to actually find slant height, but I'm going to use the slant height triangle. The slant height triangle, ABC, I'm going to draw it flat this way. We're going to use similar triangles to figure out the height from A to, I guess I'll call this point D. If I chop apart this pyramid, and this is a common trick, we've done this before, I need to know, well, I know this is 1.5. I need to find the distance from A to D. That's actually X. I know this whole thing is 12. A to B is 12. And B to C, that's across the middle of the square. That's an apothem of the square, so that would be 4.5 across like half the length of the side. And I have similar triangles here. I know that X is to 1.5 as 12 is to 4.5, and I can see that that was just tripled in the denominator, so this better be 4. You could do the cross multiplication and check me there, but it's going to be 4. So x is 4, so that's all I needed. That was the height. Okay, great. We had ones that were more complicated than this, where you knew this part, but you didn't know the total, because that's usually how truncated cones come. I mean, we would know. I mean, it'd be more reasonable if this was the shape you're trying to find the volume of, that you would know the height of it, rather than first knowing the height of the imaginary tip that used to be there. That's kind of a weird way to know that, but that makes for an easier problem because we do need the full height of the full cone or full pyramid to do the volume of the big. Okay, so there we go. 1/3 of, oh man, 1/3 of 81 is 27, I think. Come on, let me please type everything I try to. Okay, times 12. That's the volume of the big one. That's 324. The area of the small one. Okay, well, the volume of the small one, 1/3 times 3 squared is 3. Times 4 is 12. Really? That's really tiny on top. The whole thing is 324, and that little thing is just 12. Okay, so it's 312. All right, in 10, they don't give you pictures. I've drawn them for you. I don't really have any hints on that, other than you should probably know what that looks like by now, and if not, you should practice. But I guess be careful what they mean by radius and height. Sometimes they say diameter, sometimes they say circumference, sometimes, it's a little bit different. Rectangular prism, you could have drawn it like this. You could have drawn it sitting on different sides. Actually, my picture isn't that great because my 99 and my 84 don't look that similar, and the 34 and the 84 look too much alike. Anyway, finding the volume of it is not going to be any different. So we're supposed to compare these two volumes. This one is area of the base times the height, which is pi r squared in this case, times the height. That's calculator time. This volume is, yeah, area of the base times height. Now people are saying, oh, it used to be length times width times height. Now it's base times height. I'm so confused. Now wait a second. What is the area of this base? It's length times width. How is this different than length times width times height? Okay, great. Calculator time. 99 times 34 times 84. Sorry if I imitated your voice too closely there. 282, 744. 282, 744. Well, to really compare these, I can't leave this in terms of pi. I have to actually know what this estimation is. 38 squared times 71 times, not divided by, that was my fault, times pi. What? Why does it keep, oh, because it didn't register my, oh, I'm gonna punch a kitty. Okay. 322088, well, that's bigger. Point something, so it's approximately. Well, it's definitely bigger, so that one's bigger. Okay. All right, I got 2.5 minutes. Let's see if I can do this. I'm gonna have to pause and do calculator stuff. Volume of the solid. Well, this is a prism, so I need to know the area of the base, and by that I mean this face here is the base times the height. Well, the height's easy. It's 30. Okay, around here. I guess I'm supposed to assume that this is a. No, I don't have to assume. I know what that is. It's a trapezoid. I was thinking I had to assume it was isosceles, but I don't. The base looks like this. I have no idea what these two edges are, but I don't care. It tells me that the height of the trapezoid is 8, and that one base is 17, and the other one is 9. But they tell you that back here. This 9 and this 17 are actually the two bases of the trapezoid. This 9 would have to be the same length as that, so there's a 9 up there. Okay, so this is area of a trapezoid is half times the height times the sum of the bases. Times 30, because that's the height of the whole thing. So this is base right here, and that's height. Now what's interesting here is they give you this 10. This 10 is completely unnecessary. 10 would be the length here. I could use that to figure out Pythagorean theorem, something here, blah, 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 who cares? I would care about that if they didn't give me the 8, but then I'd have to know it was isosceles. Anyway, this is case by case, always a little bit different. Give me a second. I might have time. Give me a second to do some calculations here. Yeah, I didn't need to pause that, I guess. 9 plus 17 is 26. 26 times 4, but basically what that is 104, and that times 30. I think I'm going to try the other calculator emulator 3120. Okay, I've only got 45 seconds left, so I'm not going to try to make another one. I will bounce back and do another homework one now. See you in a bit.